Hello, everyone. This is John Fahey. We're going to be taking a look at one of the questions from the sample questions from the 2028 chemistry exam. So this is our question. We're going to, well, no, that's not it. This is our question. This is the 2020 sample questions question number 2, part F. And we're going to calculate the molarity of the methanoic acid from the student's data of trial for trial number 1. So the student uses sodium hydroxide to titrate a methanoic acid solution of unknown concentration. A balanced chemical equation for the reaction appears above. The student places 20 milliliters of the methanoic acid solution into a flask and uses a burette filled with 0.3 molar NaOH to deliver just enough NaOH to reach the endpoint. Incomplete data from the student's 3 trials are summarized in the following table. So here we are. Let's take a look. Let me do a new file. New. Okay. So the information in these 2 columns of the initial and final burette reading, it's superfluous. We don't need it because we have the total volume of NaOH dispensed. So we're going to convert that into liters first to work with the molarity. We have 16.67 milliliters. We're going to convert this into liters, right? So milliliters at the bottom, liters at the top. Milli stands for 10 to the negative 3. Right, so this is going to give us this conversion will give us the liters of the sodium hydroxide. Right? Milliliters of sodium hydroxide, we're going to end up with liters of sodium hydroxide. Now that we have that, we can multiply it by the molarity, which is moles per liter. So this is going to be multiplied by 0.3, 0 moles of NaOH per 1 liter of NaOH. This is going to give us the total moles. Then we need to figure out how many moles. This will give us the moles of NaOH. How many moles of methanoic acid will that quantity react with? Well, this is extremely easy. As we see from the balanced chemical equation, there's no coefficients in front of either the methanoic acid or the sodium hydroxide, so that means it's a 1-to-1 ratio. It's 1-to-1. We have 1 mole of HCOOH per 1 mole of sodium hydroxide. So we do all this out. This is going to give us total moles of sodium hydroxide that react. So one thing to keep in mind, this is an easy calculation to plug in, right? Milliliters cancels out with milliliters. Liters of NaOH cancels out with liters of NaOH. Moles of NaOH cancels out with moles of NaOH. We're going to be left with moles of HCOOH. Then we can divide that by the amount, the volume of the HCOOH in order to figure out the concentration. So doing this out, we're going to get in the calculator 16.67. We can leave this 10 to the negative 3 out because that'll just affect the degrees of magnitude times 0.3. So we'll do that out. I'll just write it here to keep place. It's 10 to the negative 3. So put this in the calculator. This calculator is only 16.67 times 0.3. 5.001. 0.0300. I should specify this in 5.001 times 10 to the negative 3, right? We can leave this as it is now. We won't round for significant figures until the end of our calculation. So when we take this and we want to divide it by the volume, but we need the volume of the HCOOH in liters. We start out again with 20 milliliters of HCOOH. 20 milliliters HCOOH. We will multiply this by the conversion factor, right? How many milliliters in a liter? Milli stands for 10 to the negative 3. Milliliters cancels out. We're gonna get 20.00 times 10 to the negative 3 liters of HCOH. You know what? We should leave it at this because when we divide them, these two exponents will cancel out, right? So the moles, so we're dividing now to find the molarity, the concentration. 5.0 times 10 to the negative 3 moles divided by 20 times 10 to the negative 3 liters. These values will cancel, right? 10 to the negative 3, 10 to the negative 3 cancel. We're getting 5.001 times, divided by 20 to 20. Okay, let's plug this into the calculator, and again, we can see what already was going to be. But we have this divided by 20, 0.25005. This we are going to round. Let's write it out first. This is going to be the molarity of the HCOOH. This we are going to round to have the least precise number of significant figures that matter for this. That was in the molarity for the NaOH. This value had only 3 significant figures. So we're going to round this to have 3, and that's going to be 0.250 molar HCOH. All right, this video was done a little quickly because it's late at night, but I will be working on making better chemistry videos than this one in the future. But I hope you enjoyed this. I hope it got you thinking a little bit about this kind of stuff, analyzing these kind of problems. And I will be uploading more in the future where I take more time to elaborate. Thank you so much for watching, and have a great night.